We are Blake, Dakoda, Dylan, Walker, and Zach, and this is our manufacturing design project where we attempt to thermoform the Georgia G. Before we begin, we believe it's important to address some of the concepts we will be talking about in this video. In our project, we explored vacuum forming, a subset of thermoforming. Thermoforming involves heating a plastic sheet, then using a pressure difference to form the plastic over or into the mold. In our case, we will be positively forming the Georgia G over the mold, as opposed to negatively forming it, which would be into a mold. So why did we pick this? Thermoforming is known for having a relatively low product-specific investment. As broke college students, this aspect greatly influenced our decision. It was important for us to be able to use common or household products from start to finish.
In order to 3D print our University of Georgia logo mold, we used AutoCAD Inventor to create an initial design of our mold. For simplicity, we decided to create a positive mold which allows for easier removal of the mold after the plastic has been thermoformed over it. After the 3D object was created in Inventor, we exported it to an STL file so that it could be uploaded to Cura. Cura is a 3D printing software that automatically extracts your 3D object and makes it readable by a 3D printer. Using Cura and the Lulzbot Taz Workhorse 3D printer, we were able to 3D print our mold, which took roughly 3 hours.
Here is the end result of the 3D printing of our positive mold.
One of the most important pieces we had to build was the shop vac. This essentially is a tightly sealed box with holes in the top attached to a shop vac. The goal is to have the plastic get sucked down and fit snug over the mold. The box was built out of 2 galvanized steel half-post bases and a tie plate used for the hold surface. The parts of the vacuum box were oriented as shown and joined together with Gorilla Tape. It's very important in vacuum forming to make sure everything is sealed tight. So we took extra precaution and made sure every nook and cranny was sealed properly, including the connection to the vacuum hose. Here we have the final assembled vacuum box connected and sealed tightly to the shop vac hose. When we began trying to pick the plastic to use, we thought it best to use plastic bowls as they are the desired thickness. We also believed the bowl shape, heated by an electric toaster oven and a heat gun, would obtain the desired even melting throughout, resulting in an evenly melted sagging plastic that would allow for a snug fit over the mold during the forming process. However, this was not the case at all. So we began trying to problem solve the issues at hand. While troubleshooting, we decided plastic bowls were not the right material or shape for the job. After some discussion, it was decided a better material to use was the front and back of a plastic folder. Once we decided on a new material, it was noted that the toaster oven would be best for evenly heating a sheet of plastic. However, yet again we ran into the same uneven heating issue. As you can see here, this was due to the oven's central heating element that heated a center line the length of the sheet much quicker than the outer edges, resulting in holes forming in the sheet of plastic. At this point, we ran into a new issue of the plastic cooling much quicker than it had before. This was due to the temperature drop outside as the sun began to set, coupled with how thin our plastic was. As shown here, to combat the rapid cooling issue, we moved our heating process indoors. It was decided the appropriate course of action was to use the heat gun as the heating element. We came to this conclusion by recognizing that while the heat gun disperses heat in a fairly central location, it was much easier to control the distribution of heat across the sheet of plastic using the heat gun. We did so by holding the plastic away from the nozzle and constantly moving an area of the plastic roughly the size of the G over the jet of heat. As you can see here, this technique resulted in the most successful attempt to thermoform the G.